Today. My name's Bart Davis, and at the time of this installation that we're going to highlight today, I was the technical consultant over the job. Joining me today is our Vice President of Technical Applications, which is Alex Zamsis, and also Ethan Perkins, who's our Vice President of Operations. And what we're going to do today is we're going to invite you to take a little peek behind the curtain just to see what goes on in the making of a Belzona repair job. And what we did was we selected a very challenging job, one that went down the day before Thanksgiving last year. And a lot of you will remember, I think every one of you will remember, especially if you were here in Texas, that back in February of 2021, they named the winter storm Uri, and it dropped temperatures down. We had snow all over the place. The kids liked it, but it was a major failure of our power grid. And so the bottom line was that Texas really wasn't prepared for having that long of a time and those sub-freezing temperatures. So much so that 10 million of us were out of power. I burned a lot of firewood. Thank goodness I had a fireplace. 246 people died in a storm, and there were billions of dollars in economic impact. So something had to change, and thank goodness we're here in Texas because people take action. And ERCOT was embarrassed, but ERCOT went into action. And what they did was they made sure that not only the natural gas could continue to flow from West Texas, which was a big problem, but that also that the power plants were properly winterized, which was a big problem. A lot of them froze up. So we fast forward to November of last year, and I get a call from a local power plant right before ERCOT's winterization inspections. And Alex, if you want to show what they showed me. So this is what they had. And that's a cooling water riser. That was one of the concrete reinforced pipes. So basically what you have is you have a steel barrel on the inside, and then the concrete is the reinforcement on the outside. And the leak was so bad, it blew the concrete right off of there. You can see it flying out. So, the first step in my process as a consultant is to not judge people. I know the situations can go from, acceptable to maybe we ought to do something about this to, oh, heck, what are we going to do? And they were in the oh, heck mode, panicking somewhat and really worried that this was just going to completely fall apart, which it's doing. It's in the process of doing right now. So I take a look at it. I gather all the information about the pressure, try to assess the defect as best as I can with all of that flow coming out and with all of that carbuncle type corrosion all over the place. And then they asked me that ultimate question: is there something that you can do about this? So the response back is, well, if you can shut it down, we can, but it's way too much of an active leak. So yeah, they can shut it down. But the first thing I do is I gather up the troops. So I'm on the phone to Alex and Ethan, and that's where it gets kind of funny. Yep. Because now the customer isn't there, and the first thing, Alex, what was your response when I called you the first time?
Yeah, I remember, and Bart's really good at finding these types of applications, and he texted me a picture of this, and in my mind, I'm thinking he wants to stop this live, and I just say no. That's my only response to him. This type of leak here live is you don't know where it's coming from, and it's coming everywhere. And Bart's really creative, and we do tackle some live leaks and some that you have to be creative. But this one looked to be a little beyond, and looked to be beyond a live leak. And you can see with all that corrosion scale, the concrete, it's just a messy looking repair. So it was one that I was like, I was waiting for the phone call after that for him to call me and tell me how he thinks he's going to repair this live. Luckily, as we'll talk about, we were able to do this down, and we'll show you how we fixed it.
Right. And we're always on site to help out the the consultants are, but this was really one where I thought BHI ourselves, our own installation arm, should get involved with it, because it was going to take a lot of skill. It was going to take a lot of know-how with the Belzona products, and we did use several different methods on this. So once we found out that they could bring it down, remember, this is right before Thanksgiving too. So our guys had a really busy summer, a really busy turnaround season in the fall. They hadn't had much in the way of even weekends off. So now we're telling them, hey, you know, we've got this thing that might go into Thanksgiving. So you don't get a lot of volunteers at that point, but we did have some of our best guys step up. And then we were able to bring in a crew that had already worked out there, grab a couple of other guys as subcontractors that were familiar with their plan, already had their site specifics, and guys that we work with all the time. So I had a very confident and capable crew to mobilize. And then really what we do is we get together, and I get together with Alex and I get together with Ethan, and we come up with a work scope. So if you guys want to help me out and describe the work scope a little bit.
Yeah, and here, as you saw that corrosion scale, you really want to blast the metal and really expose what the defects truly are. Some of the challenges on this job were, we knew that it was leaking. We didn't know how many holes there were, how big the holes were, where they were. We assumed that they were as close to that flange as possible. And we also knew that this was a concrete lined pipe, concrete on the outside. So we knew we were going to have to make a transition from the concrete to the metal, which you can see in the middle. And we knew that there was going to be a hole, and we had a feeling it was going to be either one big hole or a lot of holes all the way around the circumference. So we needed a good amount of reinforcement to seal all these holes and really stiffen up that pipe right there. So we went with the plate bond method. And then once we had all that, we had to think, well, you know, what if we have a hole right next to the flange, which was the case, as you'll see with composites or welding or anything like that. You always want to land on some good metal. You want to go at least 5 or, you know, a couple inches past your hole. You don't want to land right on your hole with your repair. So we were already thinking there's going to be a hole right by the flange. We're going to need a transition from the flange down to the pipe and extend this wrap. So we had that planned out before we got there. We already knew we're going to extend it. And then once you do all your transitions, you've sealed your holes, you're going to want to reinforce everything. So we had a fiberglass reinforced composite to go over everything. And this was our plan. And we were able to accomplish this, and we'll show you how we did it.
Yeah, and your pictures there are pretty good, because it actually ended up looking a lot like that. And you know, really what it does is it shows Alex, you know, he's got his head around it, he can see it all the way through, but now we got to break it down into steps. Not only do those steps have to be identified, but they also, somebody's got to pay for them. So that's when the work scope comes in. And Ethan, you want to describe a little bit about your how you handle that process?
Yeah, I mean, kind of like Alex said, basically we all put our heads together on what really needs to happen first. Everybody needed to be aware. The biggest issue was, after surface prep, what was this pipe going to look like? That was the biggest issue. We didn't know if we were going to have, like Alex said, holes going 360 all the way around the pipe. How many holes beneath grade under the concrete we couldn't see. So we just really had to be prepared for that. And then once we got the scope put together and sent it out, we all had to make sure that we were all on the same page. Like you said, we had a few of our best lead guys, but we also had to bring in a few subcontractors. So that was one of the main things, just making sure they were all on the same page with, if this happens, we have to do this. If this happens, we have to do this, etc.
That's right. We have a lot of control over our own people and over our subcontractors. But one of the things that Ethan always does is he makes sure that he puts in writing what the client is responsible for. So there's certain conditions that we need. There's certain things that have to happen. And then there were certain concerns on this one what you can't see in the pictures is that riser goes way up. So structurally, it looked like this entire thing could collapse. It was not well supported. So before we could even get in there, they had to move a lot of equipment. They had to do a rain for rent type affair where they were bypassing everything. They actually welded ears on up above and put in a whole new pipe support system. So they had to bring a crane in and suspend it while they were doing that. So there's just a lot of work that they had to do ahead of time. When we got there the first day, the screen that you're showing here, they said, "Could you guys come out?" And I said, "Well, it's raining. We can't do the repair. It's going to rain all day long." "Yeah, but could you just mobilize a crew? Maybe we'll get lucky. And, we kind of want you to guide us in what our final steps ought to be." So this is where it is when we get there, which gets you a little nervous because you still have an active leak. You still don't have all of the demo done on the concrete down below, and it's sitting in a foot of water. And we're supposed to maybe do this afternoon. So, making sure that the client's doing their side and helping them come up with ideas. What we ended up doing is running a diaphragm pump up through one of the vent lines in this above on that riser, running the suction down below that and just getting all that water out of there. And then we were able to advise their crew on just how much more excavation we needed so we could get back to some solid concrete on the bottom. Then, of course, what Ethan said was that we really didn't know what we had until we blasted. But now we see the area kind of cleaned out in better shape. And Alex, you want to explain what's going on here as far as QA/QC and the prep?
Yeah, so right now he has the the pipe blasted, so we're able to see all the defects, understand what we're dealing with, and then right now he's taking a profile measurement to make sure we put the right profile after blasting. So with any composite or coating, to be able to adhere properly, you need to have a good prep and you need to roughen the metal. You don't want it to be smooth. You want it to be, we blast with abrasive blasting and you create a rough anchor profile and that gives us the best bond. So he's checking his profile now. You can see we have our environmentals conditions met and we're constantly, back and forth. We're calling the guys, "Hey, how's the weather? Looks good. All right." Because you have to pay attention. If it's going to start raining at 2:00 p.m., then what you do at noon is not going to be ready for that rain. So we're constantly looking at the weather, picking the right day because you don't want to start this blast and then it starts raining on you. Then you have to come back tomorrow, reblast. So you really want to keep all that in mind.
And remember, this line itself was, concrete did a lot of the reinforcement on this line. So that's a really thin barrel type application. So the corrosion was alarming. The location, the extent of the corrosion was alarming. So we had pre-planned to overkill, and thank goodness we did. Rather than just come in for a plate bond on what we saw leaking, we decided to run that plate as close up under the bolts as we could and as far down well past the area. We like to extend any kind of repair that we do, a composite repair or a cold plate, beyond the actual leak area. And that was going to be difficult here because we found that some of the corrosion was right up against it. But also the key to it is material selection. So we picked 1121, which is our paste grade product that gives us a little bit longer working time since it's such a large area. We want to homogeneously mix that. So you're mixing up a lot of material at one time. That's where skilled applicators come in because that's a lot of Belzone on that table right there.
So, and as you can see, he's got 4 working boards and he's mixing. That's not one working board. A lot of times, like one working board is a big mix. He's got 4 working boards at one time mixing and filling that in. And you can see on the right, we were able to accomplish steps 2 and 3, which was our transition from the concrete to the pipe, which you see is that light gray section. That's our epoxy high build mortar that can be used to bond to concrete or steel and can make a nice beveled transition so we can go from the concrete to the pipe. And then we use the 2 plates, sandwich them over the defects to basically create a new pipe around the really thin area to stiffen that area up. So we had to get these plates molded to this geometry the week before, make sure they fit correctly, dry fit them, And that's another process that goes into this as well when you're doing a plate bond.
Yeah, the other thing to remember is that whenever you have extended working time, you also increase your cure. So this is not our fast curing material. We had to use it for extended working time. And remember as well that this is in right before Thanksgiving. So the temperatures are dropping. So Ethan, you want to explain a little bit what we did as far as helping with the temperature and the environment there?
Yeah, and that was also something we had to get on the same page about before we even mobilized on what we were allowed to do as far as applying heat on this material after we're done wrapping to force cure. Bart, I think we were talking low 50s for that night. Is that correct?
Yeah, that's correct.
Which would have cut our cure, which would have almost doubled our cure time. Which was not going to work for the client's time constrictions on getting this cooling water line back up and running. So we did agree to use forced air heaters that were approved to run in the plant, and we were able to get this line around, I think it was 95 degrees, Bart.
That's correct. Which
ended up cutting our cure time into probably 3 times faster than it would have been, as opposed to just sitting there in the, mid 50s. So that was really able to get them back up and running within their time frame, especially with us being pushed a day behind due to the issues we had the following Tuesday before Thanksgiving.
That's right. That's right. If I remember, all the calls were technical, but then they also added that the guy in charge at the power plant had a deer lease, and he wanted to get to that deer lease for Thanksgiving. So I heard that about 20 times. Now, what we do remember is that we had that corrosion really close to that bolt. So we did get the leak, the cold plate bond right up as close as we could, but we also have to reinforce it, and we have to add extra strength to it. So that's when we bring in the composite wrap. And you want to explain a little bit about our composite wraps and why we selected the system that we did, Alex?
Yeah, so right off the bat here, you could see what we were expecting was some holes right next to the flange. This was after our, primary inspection blast, so we knew what we were dealing with, so we knew our system was correct. And you can see on the right there, we made our transition to go from the flange to the pipe. And the thing with composites is you need as smooth a transition as possible. It's not like you can just wrap over bolts and change directions. You do need to bevel transitions as much as possible. So that's what we did with this 4141, which helped us transition from the concrete to the pipe and the flange to the pipe. And then once we were able to do all that, everything's dimensionally stable. We can come in with our composite wrap, which is going to reinforce everything, add pressure retention, add leak retention, and add rigidity to the system. So you can see, this is a fairly large pipe, 30-inch pipe, and it was about top of my head, I think it was 3 foot long wrap. And so you have to know what you're doing when you're doing composites. They have a working life with them. They have to be applied with tension. They have to be consolidated at a certain point too. You have to have your conditions. You have to have your blast. So you're constantly keeping up with your blast, because this is taking like a 2-day process. So you have to reblast at times. You have to worry about your overcoat windows. So that's why the QA/QC is crucial. Keep track of everything that went on, what time you did it, what products you used, what's the batch number, what were the conditions during the repair. And then when you're done with your repair, it's never over. You have to cure that product. So once they had everything done, then it's all right, we have to get the temperature up, we have to cure this product and get it ready as soon as possible. Because once you're done, client definitely wants to turn the pipe back on, turn the pump back on. So we have to make sure that we can do that as efficiently as possible. But the reinforcement is basically there to reinforce the pipe.
And that was a 4 wrap, 8-layer system. And then this is the final picture of that repair after it's been coated with a UV stable Belzona product, the 5111. So that's, it's a happy camper, happy hunter, happy crew because they got to go on to their Thanksgiving festivities. And then one of the follow-ups that we do is, 6 months we check it out. So we just checked this one out a little bit early because I asked a guy who's taken over this account, Stefan Trosclair, and he said that everything's holding up real well. They're happy with it. One of the things that I would like to mention is that the regulatory agency, the guys we were talking about at ERCOT in the beginning, what they did was they published where are we now, and that came in January of this year. So right after this repair, they just a couple months, they released how ready were all of these power plants for the winterization. And if you remember, we had that little brief freeze that we had just this last winter, and we did real well. No, I don't think very many people lost power in it. And they said that 96% readiness for the power grid and the power generation station. So that's a heck of an improvement to go from basically catastrophe and to up and running in good shape. So this isn't the only thing that was done to make everything better at all these power plants. There's a lot of work, a lot of money spent, and we were just very happy to be called upon when it was right at the wire. We see that a lot, don't we?
Yeah, and we were happy to work with this client. We were upfront. At first, the first want is always, can you stop it live? At times you can, but sometimes it's just you're gonna spend more time and trouble trying to stop it live. If there is a way to isolate the line, we can do a much better repair because we can inspection blast it, see what's going on. Everyone can come in and see what's going on, and then we can do a much better repair. So it was good working with them. Everything went down pretty smoothly. We were able to overcome some of the obstacles and get it done correctly.
With two of my favorite applications, plate bonding and composite wraps. I don't think it just gets much better than that in my world. And we appreciate everybody being here. To get your credits for the engineering, I believe that you need to respond. How does that work, Alex?
Yeah, if you just enter the chat and put your email, we'll send you a continuing education credit for an hour. And yeah, we appreciate everybody coming on. If there's any questions now, please feel free to unmute yourself and ask, or send it in the chat. If you have we already got one chat here. It might be an email, so we got an email. Any questions, you can unmute yourself and shoot away. So this is a pretty normal application for us. Definitely that first picture was a little bit, a little bit more critical than, but once you blast it, you can really see it, then it becomes pretty much down to the basics. Just do everything as per the procedure and as per the IFU instructions for use for Belzona products.
And the procedure that we go through here is really a team effort. That's what's so great about working here, is that we've got a lot of minds in here that have seen these things before.
All right. Well, thanks again for joining in.
We have a question there about somebody that has a similar problem, and they want to know who to reach out to. You can get a hold of any of us, but Alex is probably.
Yeah, I would say contact. I don't know. So the way we work is we have about 7 or 8 different consultants that manage each account. Once you find out who your consultant is, that would be your main point of contact, and then he works with us. If you have something that you don't know who your consultant is, you can email us at office@belzonahouston.com, and we will make sure we get a guy to come out there and take a look at it.
Hey, Alex.
Any-
Alex, this is Stefan. Jake, Paul Catapon is your point of contact. He's dealt with a lot of saltwater lines and can be there for you. I believe you have his information. So
I do. Thank you.
yes, sir. No problem.
Looks like there's a question from Keith Briggle, guys. Any bonding problems to concrete?
So the key with concrete is we have a select products that we use, and then for some of our products, you do need to add that primer. So we have a concrete primer for some of our products, and then some of our products directly bond to concrete without the need of a primer. Normally when we do our adhesion test on concrete, when you rip the Belzona off, you're ripping the concrete. So that's don't think I mentioned it in this one, but we bond stronger to concrete than the cohesive strength of concrete. And that's one of the key areas of how we repair concrete, rather than, demo and repouring.
And our product specification sheets, they will show you what the bond is to steel, but also to dry concrete and wet concrete for most of those products that are applicable. Isn't that correct, Alex?
Yes, sir. So we can do damp concrete. Typically how we prep concrete is either abrasive blasting or diamond grinding it. And you really just want to remove any concrete that's not intact. And then once you get down to some sound concrete, we bond, pretty much better than a concrete pour. All right. Well, thanks everybody for joining in, and we'll be doing this like every first Thursday of the month, and look forward to seeing you guys again.
Yeah, really good. Thank y'all.
Appreciate it.
Thank you.